Alright, today we're going to continue our talk about perimeter and area, but we're going to focus on the coordinate plane. Recall that a perimeter of a polygon is the sum of the lengths of the polygon sides, and we can use the distance formula to find the perimeter of polygons in the coordinate plane. So, our first example here, we're going to take these points, A, B, C, D, and E, and we're going to use them to find the perimeter of this pentagon. Alright, so I went ahead and I graphed them, and I connected each point to form this pentagon here, and we want to find the perimeter, so we need to find all of these sides. So I would start with AB since it's a horizontal line, so I can count these units, and that's going to give me a length of 5. Right. I don't have any other horizontals and I don't have any vertical lines, so I know that I'm going to start with AB. I know that has a length of 5 units. Okay. Then I need to find BC. Then I want to find CD, DE, and then back to A. So that would be EA. Alright, so I need to find those 5 or 4 now side lengths. And I'm going to use, we can use the distance formula, but I'm going to use Pythagorean theorem to kind of do this. So I'm going to go from here, I'm going to count how many units I go up from E to A. So I would go 3 units this way and 3 units towards the right. So EA is going to be the square root of 3 squared plus 3 squared. Which is going to come out to the square root of 18. Alright, I'm going to keep doing the same thing around the triangle. So I'm going to go now from B to C. So I need to count my units down this way. And then my units horizontal across. So that's going to be 1, 2, 3, 4, 5, 6. So this has a length of 6. And this is a length of 1. So BC is going to be equal to the square root of 6 squared plus 1 squared, which comes out to the square root of 37. Same thing with CD now. I'm going to count from C down 2 units, and then I need to go left 2, 3, 4 units. Okay, so CD is going to be the square root of 2 squared plus 4 squared, which comes out to the square root of 20. And then I need to do DE. So it's going to be 3 this way, and then 1, 2, 3, 4, 5 units up. So the distance from D to E is going to be equal to the square root of 3 squared plus 5 squared, which comes out to be the square root of 34. All right. Now it says we want the perimeter, and it says round to the nearest tenth. So in the calculator, I'm going to write that the perimeter is going to be equal to 5 plus the square root of 37 plus the square root of 20 plus the square root of 34 plus the square root of 18. Okay, and that is going to round actually to 25.6 units. Next example here, number 2. This is the triangle, and it says find the area of the triangle. So on this one, I'm going to have to use my area formula, which is 1/2 base times height. Now on this, you want to pick one of these sides to be the base. I'm going to use this side AC here as my base. So I need to find out the length of that first. So again, I want to use Pythagorean theorem to kind of figure this out. I'm going to force a right triangle, kind of using our slopes. So I'm going to go horizontal, then I'm going to go vertical. So I need to count these, and that's going to give me 9 units this way, and then 3 units up. So that means my length of AC is going to equal 9 squared plus 3 squared. I have to take the square root of that. That gives me the square root of 90. Okay, I'm not worrying about simplifying this until the end. So I'm just going to leave it like that. 9 squared is 81 plus 9 from 3 squared. 81 plus 9 gives me 90. All right? Now, so my length of AC is the square root of 90. All right, now in order to do this next part, I need to find, so my B is going to be the square root of 90. But in order to find my H, I need to kind of review some stuff. I need to find the slope of AC. All right. Since this has a positive slope, I know that this 3 right here is going up. It's increasing. So I'm going to write 3 over the run, which is 9. And I guess again, it's a positive slope, so I'm going towards the right. So that is going to be a positive 9. So my slope for this, if I reduce this, is going to be 1/3. All right. Now remember that if I want the perpendicular slope of AC, I need the opposite reciprocal. So that's going to be a negative 3 over 1. Now I need that so that I can find the height from B to this line AC. Okay, so I need to go from B, I'm going to go down 3 units here, and then I would need to go right 1. So this would be that intersection point with AC. So I would need to connect B to this new point. Right, and if we need to name it something, we can name it something. We can name it point D. Right. So my height, I'm going to use that as BD. I'm going to use, to me it's easier to use Pythagorean theorem. So I'm going to go from here, I want to go straight up. That's going to be 3 units, and then 1 unit back. So then BD is going to be equal to the square root of 3 squared plus 1 squared. So that's going to come out to the square root of 10. Okay, so now my area is 1/2 times the square root of 90 times the square root of 10, which when you put that in the calculator just like this, you get an answer of 15 units squared. Okay. Again, don't round until the end because it turns out that this actually comes out to a perfect square, and there's no square roots left in the answer. Alright, next one I'm going to use a rectangle for this, and again the area of a rectangle is going to be base times height. And I'm going to use FG and DG for my base and my height. So again, I want to count how many units I'm going this way, which is going to be 4. And then I want to count how many units I'm going to the right, that's going to be 2. So DG is going to be equal to the square root of 4 squared plus 2 squared, which comes out to the square root of 20. Right, and then I want to find FG, so I'm going to make this right triangle and go down 3 units and then right 6 units. So FG is going to be equal to the square root of 6 squared plus 3 squared, which comes out to the square root of 45. Okay. Now the area then is going to be equal to the square root of 20 times the square root of 45, which comes out to be this 30 units squared. Okay. Number 4, I'm going to leave this one up to you to do. You're going to have to kind of look at example 2 and example 3 to get this answer. On example 5, I'm going to actually show you two things. I'm going to show you one that's called the addition method, and then I'm going to show you one that's called the subtraction method, just to show you that there's a different way of looking at how to do these problems. So first, I'm going to take this composite figure and I'm going to separate it into two shapes that I can find the area of each, and then put them together. So I'm going to draw this line from A to C, so that I have a triangle ABC, and then I have this trapezoid ACDE. Okay. So what I'm going to do first is I'm going to find the area of triangle ABC. Okay. So in order to find my base, I'm just going to count, because that's a horizontal line, so I can count the units. That's going to give me a length of 8 units. This has a length of 8 units going across. Now to find the height, I'm going to go from B straight down, because that is going to be a vertical line. So this would come, since AC is a horizontal line, me going from B straight down vertically, that's going to create this 90 degrees. And so I can count, or I know I can count the units to figure out the height, so that's just going to be 2. Alright, so the area of triangle ABC is 1/2 of 8 times 2, which is just going to be 8 units squared. All right, now I need to find the area of the trapezoid. I'm going to call it ACDE. Remember that that is going to be the sum of the bases. So I know this base is 8. And I can count this base down here at the bottom. That's going to give me 6. All right, times my height. Well, if these two are vertical lines, the height is going to be right here on this edge, which is 4 units. So that's 8 plus 6 times 4. And then I want 1/2 of that, so I'm going to divide that by 2. Comes out to be 28. Right. So the area of this shape ABCDE, so my area is going to be equal to 28 plus 8, which gives me 36 units squared. Alright, for this next one, I'm looking at the same picture, but I'm going to use what's called the subtraction method. So what I want to do, or if you're going to use this method, what you want to do is you want to see what kind of shape you can make that includes this polygon here. So when I see this, I can kind of extend these out to form one big rectangle. Like so. And so what I can do is I can take the area, or I can find the area of this rectangle here, and then I want to subtract these areas here. I'll call this triangle 1, triangle 2, and I'll call this one triangle 3. Okay, and all of these are right triangles, so I can use my basic formulas for a rectangle, which is base times height, and then for the triangle area 1/2 base times height, and figure out the area of this shape ABCDE. So we'll start with the area of my rectangle. Alright, so that means I just need to count this distance from here. 3, 4, 5, 6, 7, 8. So this entire length right here is 8 units. Okay, and then I count this side here. That's going to be 1, 2, 3, 4, 5, 6. This would be 6 units this way, vertically. Okay, so this area is going to be 8 times 6, which is 48. All right. Then I want to calculate the area of each of these triangles. So the area of triangle 1, let's see if I figure this. This is going to be 2, and this is a distance of 5. So area 1 is 1/2 2 times 5, which comes out to be 5. The area of triangle 2 is 1/2. So this is 2 and this is 3. So 1/2 of 2 times 3, which comes out to be 3. And then the area of triangle 3 is 1/2 of, this is 2, and this is 1, 2, 3, 4. 1/2 of 2 times 4, which is 4. All right, so I want to take these three areas and I want to add those together. So 5 plus 3 is 8, 4 makes 12. All right, so then I'm going to take my area of the triangle, or the, excuse me, of the rectangle, minus the areas of each of the triangles. So that's going to be 48 minus 12, which gives me 36 units squared. Okay, so either the addition method or the subtraction method would give you the same answer. Alright, on this last example, I'm going to kind of leave this up to you, but I will get you started. Mike is planning the cost of an ornamental garden in the shape of an irregular octagon. Each unit of the coordinate grid represents 1 yard. He wants to lay the whole garden with turf, which costs $3.25 per square yard, and he wants to put a decorative border of stones that go around this shape. So what's the total cost of the turf and stones? So you're going to need to find the perimeter and the area in order to solve this problem. All right. Now what I'm going to do is I'll go ahead and help you get the different shapes. I would create a triangle right here, this triangle ABH. You can also connect B and E together to get a trapezoid. There. And then this would be a square. So you'll need to find the area of these three shapes and the perimeter.